The remarkable journey of Voyager 1 and Voyager 2 is a story of chance and scientific ingenuity. In the 1960s, while space exploration was still in its infancy, Gary Flandreau, a doctoral student at Caltech, discovered that the four largest planets in the solar system, Jupiter, Saturn, Uranus, and Neptune, were aligning in a rare configuration. This planetary alignment, which occurs once every 176 years, would allow a spacecraft to harness gravity assist from each planet, significantly reducing the travel time to distant worlds like Neptune. In the mid-1970s, engineers and scientists at NASA seized the opportunity and launched Voyager 1 and Voyager 2, two identical spacecraft, within 15 days of each other in 1977. Voyager 1 and Voyager 2 made history by providing the first detailed images of Jupiter's moons and Saturn's rings, uncovering surprising phenomena such as volcanic activity on distant moons. Voyager 2 continued its pioneering journey, becoming the first spacecraft to fly past Uranus in 1986 and Neptune in 1989. These missions were groundbreaking in expanding our understanding of the outer planets, and as of today, both spacecraft have ventured far beyond the reach of the solar system, continuing to send data back to Earth. Voyager 1, currently over 24 billion kilometers from Earth, holds a record as the farthest human-made object. One of the most iconic images captured by Voyager 1 is the pale blue dot photograph, taken from 6 billion kilometers away. This hauntingly beautiful photo shows Earth as a tiny pixel in the vastness of space. Despite the historical importance of the photograph, it marked the last time Voyager 1's cameras were used. The cameras were permanently turned off just 34 minutes after taking this photo, making Voyager 1 blind ever since. The reason for this shutdown was primarily due to the spacecraft's location and power constraints. At that time, Voyager 1 was positioned so far away that the Earth appeared as a distant dot. The spacecraft was also heading toward interstellar space, and the priority shifted to other scientific instruments to study the transition beyond the solar system. The spacecraft was running on limited power, as it was fueled by a radioisotope thermoelectric generator, RTG, which was slowly degrading over time. To conserve power and extend the life of the spacecraft, engineers turned off non-essential systems, including the cameras. The camera's power consumption, which was around 40 watts, was deemed too high to justify keeping them on when there were more critical instruments to operate. At the time of the camera shutdown, Voyager 1's power output had dropped to 57% of its initial capacity. Each photograph the spacecraft took required around 5 million bits of data, or about half a megabyte, to be transmitted back to Earth. However, the data transfer rate had significantly decreased, and it would now take hours, around 21 hours, for a single image to be sent back to Earth due to the spacecraft's distance. By the mid-1990s, the data rate had slowed down to just 160 bits per second, making it even more difficult to transmit images. Despite the camera's shutdown, Voyager 1 continues to send valuable data. It is still communicating with Earth, relaying information about the interstellar medium and cosmic phenomena. However, because the spacecraft is now 23 billion kilometers away, there is little to photograph. The Sun, although distant, is still about 16 times brighter than moonlight on Earth, providing enough light for basic imaging, but there is nothing of substantial size to capture. The star constellations that were once visible from Earth remain unchanged, and the view from Voyager 1 is largely unchanged, with distant stars appearing as tiny dots. If the cameras were turned back on, they would capture a dim and lonely view of the cosmos, with only distant stars and the Sun visible as faint pixels. Even though the images would be of minimal scientific value due to the lack of objects nearby, the sight would still be extraordinary, as Voyager 1 continues its journey through interstellar space, which will last millions of years. Even after communication ceases and humanity may be long gone, Voyager 1 will continue its silent voyage, capturing new perspectives of the universe as it travels through the cosmos. Today, as the Voyager spacecraft near the end of their operational life, scientists reflect on the success of these missions that have far exceeded their expectations. The Voyagers have not only broken records by traveling farther and lasting longer than any other spacecraft, but they have also opened new frontiers in space exploration, revealing the wonders of our solar system and beyond. Their journey is a testament to human ingenuity and curiosity, and their legacy will continue long after their communication with Earth ceases. In conclusion, the decision to turn off Voyager 1's cameras was driven by the spacecraft's diminishing power and the need to prioritize other scientific instruments. While the spacecraft continues to provide invaluable data about interstellar space, the era of capturing images has ended. Voyager 1's journey through the cosmos, though, will continue for millions of years, as it quietly carries a message of human exploration across the universe. The pale blue dot remains a powerful reminder of Earth's fragility and our place in the vastness of space, a legacy that will live on for generations to come.